Hello everybody. In our series Basics of Life, today we're looking a bit more closely at our solar system, at the planets and their past. So we're going to discuss the NICE model, the late heavy bombardment, and a lost planet, or even two lost planets. So the overview of the video is first, Kepler had this idea of the clockwork of our solar system, and in a similar vein there's the Titius Bode rule that kind of says something is mathematically given in the solar system, although it's not perfect, and there's the problem probably. Then how was the planet formation in the solar system, and then the NICE model by Morbidelli and colleagues that has mainly to do with the outer planets and lost planet maybe, and then we will also look a bit at the inner planets, although the relationship between outer planets and inner planets is still not clear enough yet. So first, to come to Kepler. Kepler had to accept at least that the orbits of the planets are not circles but ellipses. He accepted that, and that allowed him to describe the orbits and the time and distance relationships much more accurately than before Kepler, where people worked with epicycles and these strange things because the Earth was in the center, and Kepler could fix the Copernican system by introducing ellipses. And then he kind of concluded that everything is fixed and has been like this almost forever. That was his idea, and this is the clock that symbolizes that. Or there are these clocks that actually show the planets and how the inner planets move fast and the outer planets move more slowly. Then there's this famous Titius Bode rule, and I still can't tell you exactly how it relates to the rest of this video, but it gives a mathematical description of the distances of all the planets, including asteroids, until Uranus, and it fails for Neptune. And this is the question, why does it fail for Neptune? Is the rule wrong, or does the rule describe an ideal situation that may have existed or the solar system is tending towards, or things like that? And Titius and Bode, I think, independently had this idea of this formula. So A is the average distance of the planet from the sun. And if you write everything in astronomical units, then you can start the m with a minus infinite, and then by 0, 1, 2, 3, and so on. And here they tell us that actually Pluto would be m equals 7. Although, as we know, Pluto is not alone out there. There are more of these bodies. There may be even a larger planet. We don't know yet. The discovery of Pluto was quite accidental because Pluto is icy, has a high albedo. Otherwise, it would have been plainly impossible to see Pluto back then, 1930, when it was discovered. And is Ceres a planet? It's a dwarf planet at least, and has 1,000 kilometers diameter, but here in this rule it counts as a planet. But it can be discussed if Ceres stands for a larger planet. It was lost. We will discuss this later in this video. But it's funny how these distances follow this exponential distribution. So for Jupiter, Saturn, Uranus, it's quite the case that each planet has double the distance from the planet before. And the question is this a function of the material that was there that the planet could incorporate, or has it something to do with waves, with wave functions like the electrons that going around the protons, this kind of thing. And these days we can compare these to other planetary systems around other stars, which is quite interesting, which shows us that our solar system is quite strange, as we have discussed in earlier videos. But the Titius Bode rule is there. It's not counting for Neptune at all, but the other planets fit quite well. Here they gave the deviation in percent, so it's never more than 4 point something percent, which is quite good, I think, for a simple mathematical approximation. So we keep this in mind, just that as something funny. The Nice model is actually not one model, but a series of models. And it is tightly connected to this late heavy bombardment. People were looking at the moon and were wondering when the largest craters were built. And for a while they thought that many of the largest craters were built some 3.9 giga-years before now. Although later data has shown that it's actually not, this peak here doesn't really exist. It's more or less a smooth decline. But fact is, some planets cooled down quite quickly, and the moon was built in this catastrophe, as we've also seen in earlier videos. And then something happened that made these very large basins where the magma came up and filled them up, and so the Maria on the Earth side were built. And the question was why. So Morbidelli and colleagues came up with this idea that during the building of the solar system, the orbits of the planets, especially the giant planets, were not stable. So most of the planets wandered outward and Jupiter wandered inward. The inward wandering is relatively easy to explain. As long as a planet still collects material, it breaks him down and it will wander towards the sun. And this could have been very devastating for the inner solar system, because Jupiter is very large and it could have destroyed our planets, or kicked it out of the solar system, which we will see that this is something quite common. So here the idea is that they used to be closer together. Jupiter went inward, the others outward, and the outermost, Neptune, collided with these many bodies of the Kuiper belt and collected some of them, and Jupiter also collected some bodies from the asteroid belt. And this nicely explains why Jupiter and Neptune have lots of Trojans and Saturn and Uranus not so many. And the other thing is, why does Uranus has this tilt this 98 degrees tilt, and this we will see that later. Some have moons with strange forms, some of the huge planets, and some moons go around the planet in the wrong direction, which is normally hard to explain if the moons were built close to the planet. And the influence on the Kuiper belt can be seen because there are the scattered disk objects. So part of the Kuiper belt has a very strange orbit around the Sun. I think Sedna is one of these. It's a really eccentric orbit. This I've already shown you. The NICE model was built to explain this late heavy bombardment, because normally you would expect just a smooth decline, a decline like this. And there was a smooth decline, but not as quickly as people would think. So it's possible that something happened here. And I mean, if the giant planets disturbed the whole solar system, all the comets and asteroids there, it's conceivable that many came into the inner solar system and collided with the inner planets. And actually each planet has marks of, maybe except Mars, has marks of large collisions. Mercury has the Caloris basin that is huge. And Venus turns the wrong way round, which basically means that, like Uranus, it has been reversed, it has been hit, and the axis has been turned around. And in the Earth, the Moon was built in a catastrophe. So catastrophes were frequent not only in the outer but also in the inner solar system. Then, how are planets formed? And here becomes a bit complicated. Planetesimals and planetary embryos started to form quickly. And the gas giants were finished first, before the gas dissipated, because the sun blew the rest of it away, and then they couldn't grow anymore. So it must have happened quite quickly. And the Earth growth was complete a bit later than the giant planets. And almost at the end, the Moon was formed in this catastrophe. Mars should have grown faster than the Earth, according to the Weather model. And the question is, where has its mass gone? Or there are newer models that try to explain that Mars is small. It has just 11% of the Earth's mass, and it's also much smaller than Venus. Newer models are, for example, the low mass asteroid belt model that says there was an inner ring between Earth and Venus, and this inner ring was dispersed and formed basically Earth and Venus, and some rests of it went into Mercury and Mars and asteroids. There is some evidence for these belt models, because some of these belts can be imaged around other stars. There's the pebble accretion model, and it says that pebbles and planetesimals are different. Pebbles are rather dry without gas and smaller, I think. And the pebbles form away from the planetesimals, and planetesimals were more often found in the outer solar system. And this would actually predict that Mercury has most of the mass, which is not true. Then there's the convergent migration model, which says most mass is in the middle, which is actually true. And there is also the grand tack scenario, which I always tell the people in the observatory Jupiter came inside and ate out lots of mass, also of the mass that should build Mars. And then, fortunately, Saturn took it outward once most of the planetesimals were eaten up by resonance. But there is also the Early Instability Model, which assumes a fat Kuiper belt, which was kicked out much further. And also one of the giant planets was kicked out. That's part of the Early Instability Model. And there's a paper that says that this model is the one that can best explain the late heavy bombardment phase. It's just easier to explain when one planet has been kicked out. And this could help to explain the outward migration of the other giant planets, except Jupiter, that came inside. And even two are possible. And maybe by being kicked out, the one or two planets could have harmed Uranus to look the way it looks now. If you're interested, you can read this in Clement et al., very new paper. But the question is, how can you turn around Uranus without dispersing the moons that are still in resonance? That's something that is quite hard to explain. When you do something to a planet, the moons are gonna run away, basically. So this is one open issue. There are issues of the Nice model. When was the exact time point of the instability? That's something hard to get. Why could terrestrial planets still form and are still here? That's something I already mentioned earlier, that this is strange in the solar system, that we have large planets and smaller planets, because in many solar systems you have either large or small planets. Normally, depending on the mass of the star, so larger stars tend to have larger planets. And what triggered the instability? As we've seen, the Early Instability Model seems to work best. But still the time frame when did what happen is still quite not fixed yet. And there are also problems in the inner solar system. For example, some bodies are on the wrong side of the snow line. Ceres is quite an icy body and is quite close to the sun, actually. And again, why is Mars so small? That's also something that has to be explained still. We discussed about Mars in a recent video, and that this smallness is actually something that clearly limits its habitability. Was one more planet kicked out, which means one of the inner solar system? There are some hints for that assumption. And the planet that doesn't exist anymore should have had a radius of at least 1,000 kilometers. This has been shown with these angrite minerals that form only under high pressure, which means in the inside of a larger body. And they have been found in this meteorite, Northwest Africa 12774. And so people assume that this meteorite comes from a planet that has been destroyed. There are more data speaking for that, namely the Psyche asteroid that consists of a naked metallic core. So this could also stem from a planet that has been completely destroyed. Not kicked out, but destroyed. So parts of the core are still there and lots of material was dispersed far around. So this is just to tell you it's not like Kepler thought. Things can go right for a very long time and all of a sudden something happens that kicks a planet out or makes a former planet become a moon or things like that. So as a graphic summary, which I don't do very often, but I like this graphic, the gas giant planets form and migrate. And there are leftover comets and there are leftover silicates that will later build the inner planets. And then UV and X-rays from the young star, should be star, not star, evaporating the disk from inside out. So the gas goes out. But there's still enough material for the inner planets. And as you can see here, Jupiter tends to come inward. And here something happens. One of these extra ice giants was kicked out in this model. And Uranus and Neptune are still there. But then as soon as this one is kicked out, the outer three use the space they got and move outward. So, and this is more or less what the solar system looks now. So the inner rocky planets are quite close together, and then there's the asteroid belt that doesn't contain much material. I think not more than a couple of % of the Earth's mass. And then Jupiter and the other giant planets have moved quite a bit outward, which explains again the scattered disk objects from the Kuiper belt. So again, Uranus should be looked at to try to determine what happened to it. It's quite an odd planet, but very interesting. So thank you a lot for the attention. Stay curious and keep looking up.